Hey everyone, all right, so here we go. We're going to continue with graphing quadratics in standard form. If you're having trouble, please get on Zoom. Let's have a Zoom chat. Let's talk about it and pretty much clear up any confusion that you have right now. So we're going to spend the next 2 days working on this worksheet. Make sure you watch entirely so that you don't do too many problems today. I'll tell you exactly what you have to do, and we're going to keep on moving through this. So we are going to work on the evens, although I am going to give you number one because I think it can be a little difficult if you look at it at first. Also, given that we haven't really done this too much, so I'm going to help you out. Number one, for any quadratic of the form y equals ax squared plus c, the axis of symmetry is always the line x equals 0. So basically, just to talk to you a little bit about it, by being in this form, the graph is only going to move up and down. It's where we kind of talked about this a little bit at the very beginning, which was last week, where when we have something of this form, the only thing that's going to change is the graph could be lower or the graph could be higher. But no matter what, right down the middle is still x equals 0. So that's where that comes from as far as the axis of symmetry. Okay, number two, if the axis of symmetry of a quadratic is x equals 2, and -1, 3 is on the graph, then what other point must also be on the graph? One of the other big qualities we've been talking about with quadratics is that it is symmetrical. The axis of symmetry splits the graph up evenly. So here's what we can do. Draw ourselves a little axis right here, okay? X equals 2 would be right there. -1, 3, just to estimate, would be somewhere right up there, right? Notice it is 1, 2, 3 spaces to the left of the axis of symmetry. So what we need to do is we need to go 3 spaces to the right, 1, 2, 3, and that is where what we call our reflection point would match up. That's another point on the graph. What are the coordinates? 1, 2, 3, 4, 5 over, and it's got to be the same up, so 3 up. So 5, 3 is another point that would also be on the graph. Okay, number 4. The graph y equals 2x squared plus 4x plus 3 passes through the point 1 what and -1 what. So how do we figure out what those y values are? We've been trying to practice this a little bit here. In order to find y values, you have to plug in x values. So we want to plug 1 into the equation, plug -1 into the equation. Okay, be careful. We don't know that, oh, well, if we get what we get for 1 is going to be the same for -1. That would only be if the axis of symmetry is at x equals 0, which we don't know that it is in this case. So we have to plug both of them in. Okay, so take a second. Let's see if you get the right answer. So this is good work in practice plugging these into your calculator. Make sure when you plug into the calculator, I can't stress this enough, you use parentheses. So anytime you plug in 1, put it in parentheses. Anytime you plug in -1, put it in parentheses. Okay, so pause the video, give it a shot, see what you get, and then let's see if we have matching answers here. All right, so when you plug in 1, you are going to end up with an answer of 9. And when you plug in -1, you're going to end up with an answer of +1. Okay, so 1, 9 and -1, 1. So just to give you even a little bit more extra positivity going here, I actually really like this worksheet. I like these next couple of problems because I think they lay everything out real nicely on what we've been trying to do, graphing quadratics in standard form. Let's take a look at number 5. For example, the first thing I've been trying to preach and telling you to do is to figure out what is the A, the B, and the C. Write it out. So in this case, A would be 1. B is -4, C is 8. If you still have no idea where those came from, you need a Zoom chat. That's unacceptable at this point. You need to know where those come from. Does this open up or down? It opens up. Vertex a max or a min? It is a min. Once again, if you are not able to get those, you need a Zoom chat. Okay? If you think you're just going to keep skating by because the only thing I'm checking right now is for completion, you are sadly mistaken. We are working on bringing out assessments. Okay? Last thing you want to do is get a couple of nice 10 out of 10s for the completion and then do terrible on the assessment. Don't let it come to that. Y-intercept. Put the shortcut here again. The shortcut for the y-intercept is you want to make x equal to 0. So if you take 0 and you plug it in for the x's, see that you're going to wind up with an answer of 8. So 0, 8 is your y-intercept. Axis of symmetry, vertex, remember, they go hand in hand. So we have some space. We'll do our work here for the x equals negative b over 2a. We'll just do that right here because we have the space for it. So negative b would be a negative 4. So that really turns into a positive 4. 2 times a, 2 times 1 is 2, and 4 divided by 2 is 2. So our axis of symmetry is x equals 2. Again, we also know that's the x coordinate for our vertex. We want to find the y coordinate. We got to plug in 2. So y equals, parentheses, 2 squared, minus 4, parentheses 2, plus 8. As I said, if you're plugging something in, put it in parentheses. This way, right now, you could take that entire statement there and plug it right in your calculator, one shot, and it gives you the answer. And what you would end up with, let's see, 4 minus 8, negative 4, plus 8, you get an answer of 4. So your vertex comes out to be 2, 4. So we can plot the vertex, 2, 4. We can plot our y-intercept, 0, 8. We have our axis of symmetry. And as we saw in problem 2, let's add on our reflection point here. What matches up over here to the y-intercept? So notice the y-intercept is 2 spaces to the left. So if we go 2 spaces to the right, we can add another point to our graph, and then we can connect the dots to actually make our graph. And actually, the last problem for today is we're going to jump down here to number 8. All right, so the a value, negative 3 over 2. There is no b value because there's no x. C would be a value of 3. Remember, just a regular number, no variables attached to it. That is your C value. Does this open up or down? It's going to open downward because of the negative a value, which means that the vertex is going to be a max. What is the y-intercept? We'll plug in x is 0. When you plug it in, you'll see you'll get 0, 3. Axis of symmetry, negative b over 2a. So that would be really 0 over 2 times negative 3 over 2. And anything with 0 on top always comes out to be 0. And so vertex, x coordinate is 0, axis symmetry, x is 0. And if you kind of already noticed, the y-intercept, 0, 3, nothing's going to change when you plug in 0 again. We would still end up with a y coordinate of 3. So we can plot 0, 3 on the graph. We can plot our axis of symmetry right at x equals 0. And notice down here, find the coordinates 2, blank and negative 2, blank. How do I know that I'm going to get the same thing in this case for 2 and negative 2? Well, I know because they're both the same distance from the axis of symmetry. 2 is 2 to the right. Negative 2 is 2 to the left. So really, if I find one, I'm going to find the other. So let's say we take 2 and we plug it in. So negative 3 over 2, parentheses, 2 squared, plus 3. Okay, so if we plug that in, you're going to get negative 12, negative 6. That's going to come out to be negative 3. So we get an answer of negative 3. So 2, negative 3, negative 2, negative 3. We can now connect our dots. And make our graph. All right, real easy today. All I want you to do for homework is number 3, number 6, and number 7. So that's 3, 6, and 7. Finish that up. Take care of anything else. Remember, I posted it on Google Classroom. Your factoring brochures are due next Monday. That's a week from today. Even if you do one section at a time, you will have it done by Monday. All right, enjoy the rest of your day, guys.